I think let me put it like this. So for this case, let's say if say if we have P2 and we say if P2 is 401 Newton, it will go up, right? But consider this case if we have say if we have 401 newtons, this block B will go up. And if the force is smaller than 401 Newton, or I release the hand, block B will fall down, right? So, but in our case with a wedge, it is different. If we have P and P, okay, and we have say we have 423 newtons here, and then we say we remove the force. Block B goes up if T is equal to 423 newtons, it's okay. But if the force is no longer there, if the force is removed, and block B will stay at a new position, and it will not fall down. It's okay. These two are different things. So it is although we need a 423 newtons to the left, that it is still okay to do it. In practice, we will simply do this. That we X forces like 423 newtons in the like this. We call them impulses. And actually, we use a hammer. We use a hammer to hit block A to give forces higher than 423 newtons at a short time for a short time. Then it will go up and up and up by small steps. Okay. Okay, so if there is one moment, there is a very short time that the force goes above 423 newtons, then it will go up a bit, and then it will stay there, and then when we have another hammer hit, then it will go up a bit, and then it will stay there, and then we go up bit by bit. It's okay. So it is different from the concept. It is different from having a constant force holding the block. Because for this case, if we use a constant force to hold the block, we need to give the force as long as we want the block B. Once block B there, if the force is removed, that it will go down. It's okay. So after it's okay. So these two are different things. Now, and we have another. I want to have a look of another problem. And if you are after you draw this, please go to the next page, problem 8.59. Take your time to draw the figure. And for this kind of problem, that the key thing is to draw the friction force in the right side. It should be calculation should be easy. The difficulty is to draw the three-point diagram. Now, if after you have marked your handout, that please go to the next page. Now, and we go to page the next problem, and the wedge is having 10 degrees, and the rod AB has a weight of has a mass of 5 kilograms. So, and the coefficient of static friction. So is this mu S or mu K? Is this one mu S or mu K? Mu S. Okay. It's 0.4 between the wedge and the rod. Wedge is this one, rod is this one. So 0.4 is between the two. And between the wedge and the floor is 0.2. Determine the smallest force P required to raise and B of the rod. So, and it is very similar to the last problem. So let's draw the free force diagrams. A and B, and then we have block. B here, and I think I should. And here, we have, let me draw the, let me put the force P here. And this one is 10 degrees. And this one, the radius is R equals to 0.2. So we have a picture here. So let's do it bit by bit. Let's draw the forces. So what's the type of joint at point A? Point A is pin joint. So we have AX and AY. take your time to draw it. Next, the rod AB has mass of 5 kilograms. Right? So where should we draw this 5 kilograms or say 49 newtons? It has a weight of 5 kilograms or 49 newtons. Where should we draw the force? So it is it acts on the centroid of the rod. So it should be 2R over pi. And at last we have this surface to not the last, but we have this surface to talk about. And for this friction force, you may ask the friction force whether the friction force is in this direction or this direction, right? The friction force can go to the right or go to the left, right? So which way is it? So sometimes it is not easy to know because it can go to the right or it can go to the left. So what should we do? We draw the free body diagram from. Now we can draw the free body diagram from this side. Okay. Of course, we have friction force here, but is it to the right or to the left? We don't know, right? So we can move to this one. We work from here. So the left for the external force P is to goes to the left. So all friction force here go to the right, right? It's okay. So here and we have R R2 going this way, and this angle is phi S1, phi S2, sorry, phi S2. Because the external force P goes to the left, so these friction forces go to the right. It's okay, because of course the friction is opposite direction. Now, and for the upper one, remember, and the angle is the relationship between and the friction force and the reaction force are related to surface normal. Okay, and there is because this one is 10 degrees, this one is also 10 degrees, and this is surface normal. Therefore, and this one is R1, and this one is phi S1. And because this one goes to the right, so on the rod it should go to the left. Okay. Sometimes if you are stuck at the finding the direction here, go to this one first, and then we look it back. Okay, before we and from here you can we can do we can do the calculations straight away. We can start doing the calculations, but you can do some simplification before going forward. So can we do something on AB? After you draw the free body diagrams, think about if we can do something on AB. If you can do if we can do anything. So how many? So at how many points do forces act on the body? So these two forces act on point A, and R1 acts on point B, and this gravity acts along this line. So this is a free force body. So what do we know about free force bodies? And the lines of action of these free forces would go to the same line. So for the reaction at point A, then it should go like this. Of course, it depends whether you can use this or you don't use this. You can do this step or you don't do this step. It is okay. But if you want to use this step, then it will help you. It's okay. Now we go to, if you are fine, then we can start writing we can start the calculation. If first because we know the known quantity 49 newtons is here, so we determine R1 from 49 newtons, and then we determine P from this free body diagram. Okay. We first, because the known quantity 49 newtons is here, so we determine R1, and after we know R1, we determine P. I'll work on the first step. For the first step, what should we do? For example, we can say MA, summation MA equal to 0. It means negative 2R over pi times mg minus R and R1 times 31.8 degrees plus R plus R times R1 times cosine 31.8 degrees. Oh, sorry, and I forgot one step. And because we have these two mu s and two values of mu s, these two values of mu s are related to these two angles, right? So we write them down. Remember remember what we had last week. So we have 21. It's okay for these two. So after because this one is for the and this one is for the horizontal force, and this one is for the vertical one. Of course, you can use factor, but in this case, I think. And R1 is equal to 96.68 newtons, and angle is 31.8 degrees. My writing not good enough. Horizontal. And this is what this is EAL. Sometimes if you can't read my writing, please let me know. You can say during the class or after the class. Now, and for this one, we use the free body diagram of AB to determine R1. Now we go to this one and we can work out P. And let me draw the force polygon, and you can determine the value at home. P is here, and we have R2 with R1 here, and with R2 here. And this one is 11.3 degrees, and this one is 31.8 degrees. And of course, you know how to, because we know this one is 96.68 newtons, and you know how to get P, right?